So in one of the previous videos, we discussed the technique of gradient descent and how it can be used to find the values of m and c which are going to give me the minimum cost. Okay. So we discussed that we are going to take the random starting value of m and we are going to slowly come down by using the equation m1 is equal to m naught minus L into d cost by dm. Okay. So L was going to be a learning rate which we are going to decide for ourselves, and d cost by dm was basically the value of the gradient. Okay, gradient of the cost with respect to m, right? So if I see, this is the equation of my cost, okay, and d cost by dm is going to be 2 into mx plus c minus y into x dot mean. Okay, so obviously this summation and by n is going to give me this mean. This 2 is going to come in front while I am doing differentiation, and the coefficient of m is x, which is going to come over here. Okay, so similarly I will find d cost by dc, which will be given by this expression, right? And then I will basically use these equations. I will have to choose the value of m naught and I will have to choose the value of L. Okay, right. To implement this, I will be using my dummy data, which we have already seen while discussing linear regression. So if you remember, our data set looked something like this: 1, 2, 3 and so on till 200 data points, and we had one x and we had one y. Okay, so I'm going to have one m because there is only one input feature, and c, that is our intercept. Okay, so so let me choose a learning rate. So I'm choosing 0.0001. Okay, so if this learning rate is too slow or too fast, we are going to change it accordingly. But let's start with 0.0001. Okay, yeah, and number of iterations I'm taking as 100. So I'll try and come down 100 times. Okay, and I expect that within those 100 iterations, I would be able to reach my m, which will give me the minimum cost. So now I'll do one thing. I'll just write a function with the name gradient descent, which is going to take all these values from me. Gradient descent, which is going to take data, learning rate and iterations from me. Okay, yeah. So I'll simply call gradient descent from here. Okay, so I expect that it is going to give me the value of my final m and c. Okay, so in the end I am going to just print it. Yeah, so let's write our gradient descent function. Let me choose initial value of m and c. Let me just choose 0. We can start with any value of m and c, as we have already seen. Okay, even if it's on the right side or it's on the left side of required m and c, it's not going to matter. Okay, so x is equal to data 0, and similarly I have y is equal to 1, right? So I have just separated out x and y. Now I will run the loop 100 times. Okay, because I have value of iterations as 100. So I'll just write for I in range iterations. Now I'm going to update the value of m and c basically 100 times. So m and c is equal to, I'll just write a function, update function over here. Instead of writing the whole code in one function itself, I'll just break it into different functions so that the code is more readable and it is better. Okay, so update, my update is going to take, let's say, y, m, x, c, then it's going to take learning rate for me. Okay, I think these are the required things which my update function will need, and finally I'm simply going to return my final m and c. Okay, so one thing what we have to do is we have to write the update function now. Okay, so let's just write the update function over here. Define update. Now it needs these values. Okay, now first of all, gradient of m is equal to, as we can see over here, so this is our gradient of m. So and gradient of C, it's going to be almost similar, but we are not going to have x over here. Okay, now we are going to use our equation, that is m is equal to m minus learning rate into gradient of m. Okay, gradient of m, and similarly we are going to do for C also. So C is going to be C is equal to C minus learning rate into gradient of C. Okay, so this is going to return me m and C, right? So let me just run my update function. Let me run the gradient descent function, and let's see what the final gradient descent comes out to be. Okay, so there is an error, mx is not defined, so obviously I'll have to write m into x. Yes, so this is the value of m and c we are getting. Okay, we are getting the value of m as 1.008 and the value of c is 0.012. Now let's do one thing, let's quickly plot our graph and check whether this value of m and c is able to give me the best fit line for my data. Okay, so I'll quickly import matplotlib. So I'm just going to take two values of x, any two random values, np.array. Let me take 0 and 100. Then I am going to calculate corresponding values of y using m into x plus c plt.plot x comma y. Okay, this is going to be my line, and I'll also scatter all of my points over there. So x comma y. Okay, let me give color as red. So plt.show. Okay, so this is the line that I am getting, and I can see that my line is able to explain the data pretty well. Okay, another thing that I also want to do is that for each of the iterations we were basically updating our m and c values. Okay, so our m and c values were getting updated after every iteration. Now I also want to check that for every iteration what was my value of cost. Okay, obviously the cost should ideally come down with every iteration. Now let's try and print the cost for each of the iteration. So I'll just write a cost function. So define cost. It is going to get data, value of m and value of c. As we already know, the equation of cost is this. Okay, so basically it is the summation of all the errors, right? And we have to take the mean of it. So let's initialize our total cost is equal to 0. Okay, then let's say n is my number of points, that is there are 200 points length of data. Okay, and for I in m, basically you have to do the summation for all the points. X is equal to data I comma 0, again I'm doing the same thing, and y is equal to data I comma 1. Now total cost plus is equal to 1 by n. Okay, so not I but 1 by n into y minus mx plus c square. Okay, m into x, this time I won't write mx, plus c. So instead of writing the bracket I should just write minus over here, into 2. That's it. Okay, so I think this should do the job for me. So now I'll simply return total cost. Okay, I'll just run this function, and with every iteration I'm simply going to print cost. So I'll print cost. So I'll just pass these values to the function data m and c. Okay, so I'll just rerun this function again, and if I try to do this, so there is an error, name cost is not defined. Okay, so basically the name of the function was capital C. Okay, still some error, name m is not defined. Okay, so where am I using m? So here it should be n. Okay, so these are basically the costs after every iteration. Okay, so we are starting with 341, and at the end of the 100th iteration our cost is 9.215. Okay, let's also mention the iteration number while we are printing. Let's write I comma this thing. So first iteration has given me 341, then the last iteration, that is the 100th iteration, has given me 9.215. As we can see, we were able to reach our very optimal value in the 4th or the 5th iteration itself. Okay, because we were able to choose a good learning rate. Let's try and take a small learning rate. So as we can see, because of the slow learning rate, we are coming down very slowly. Okay, we are coming down very slowly. So this is the importance of taking a decent learning rate. Okay, so of course we'll just get to know after we check the costs that whether we are coming down too slow or too fast, and we can take it accordingly. So I think 0.0001 was doing a good enough job. Okay, so I hope it is clear how we have implemented gradient descent for one variable. Thank you.